Hello everyone, this is Sumit K and welcome back to my channel. In this video, we are going to see a cloud native load balancer in Google Cloud, and we will implement this cloud native container load balancing with the help of network endpoint group. So how network endpoint group is useful for container native load balancing in Google Cloud. So if you don't know about what is network endpoint group, then I would highly recommend to watch my previous video where we have talked about what is network endpoint group and what are the endpoints, how many types of network endpoint groups are available. And then we have talked about the journal network endpoint group, and we have seen the demo. So you must watch this my previous video and then come back to here, and then you will be able to understand what we are going to implement here. All right, so container native load balancing in Google Cloud is basically the place where your global load balancer directly, forward the traffic to the pods, right? So you can see that you have two diagram on the left hand side. This is your container native load balancing, and in the right hand side we have a default load balancing. So let's talk about first default load balancing, how default load balancing works. So when you create a GKE cluster, then you need to unselect this VPC native, right? So this is a traditional way of balancing the traffic, where the traffic is hitting onto the instance group in your backend service, and the backend service is going to target your instance group, right? So this is your instance group where you have two nodes, and in your both the nodes you have few pods, three pods in here and three pods are here. So the traffic is flowing from load balancers to instance group, and from instance group it is going to the IP table. So kube proxy is on every node. So the kube proxy is the one who consult with the IP tables and then forward the traffic to the pods. So you can see that there are multiple hops, right? So whenever the traffic will forward, will reach out to your instance group, it is going with the round and robin fashion, round robin fashion, right? So the first request is hitting to node 1, the second request is hitting to node 2, and then and then it is going so on. So there is a problem, right? You are basically the load is balancing here on the instance, not on the ports. So so that's why the load balancer sends traffic to the instance group, and then Kubernetes used these IP tables for routing using Kubernetes service, as you can see in the kube proxy. So in the on your left hand side, this is a container native load balancing, where we have used NEGs. NEGs are the journal resource that represent a collection of IP address and port combination, and it can be used as a backend for HTTPS or maybe for TCP proxy or SSL proxy based load balancing, right? So it improves the network performance by eliminating the IP table swap, right? So traffic is distributed directly to the ports. You can see that from here, it is directly to the ports, and it eliminating the IP table or from the default load balancing. In the default load balancing, here you have the IP tables in picture, but here the IP tables has been eliminated. So network endpoint group does not manage VM instance. Instead, it is a collection of network endpoints represented by the IP ports and pairs, right? IP port pairs, basically. And the collection of the IP address and port combination allow network endpoint groups to target ports directly. Each pod has its own IP port combinations. Using the network endpoint that allow container native load balancing to distribute traffic in a granular fashion amongst the containers running within a single VM, because it eliminates an extra hop of IP tables. Both latency and throughput of load balancers are getting improved here. So that is the benefit of having the cloud native load balancer, which is feasible because of the network endpoint group, right? So what differentiate, like if you are creating the cluster, two clusters, let's say one is with cloud native and another with the default, how do you differentiate it? So when you're creating the default load balancer, you have make sure that that is it's also called traditional way of load balancing with the instance group, and it also called route based GKE cluster. So I'll show you the routes when we create two clusters. And here the main key point is the no VPC native. So whenever you create a GK cluster without VPC native, you'll make sure that this option is unchecked. And with the cloud native load balancer, the VPC native is must, because the VPC native is something that will create a secondary IP range. So when you create a GKE cluster, you get a host, right? You get a node, and then you get a service, and then you get a port. Then the host is needs to have the IP ranges, which will come from the primary range of your VPC, and the node and the service will also get the IP ranges from the secondary IP range, which we also called alias IP range. So I'll show you when we create the cluster, the VPC will get a secondary range. It will also get the alias range, right? So that's why all the routings and everything will be taken care by the Google Cloud. So you will see that the routing is now has been reduced in the cloud native load balancing if you compare it with the default load balancing GK cluster, right? And in ingress, I'll talk about this when we see the demo. All right, so what we are going to do now, we create a two cluster. I will create a cluster without with the default default load balancing, and we will create another cluster with a cloud native, or with the network endpoint group. So one cluster without network endpoint group, and second cluster with network and endpoint group, and then we will see the. So let's move on to my Google Cloud Console. I'm into my this project, and I have set up the Kubernetes engine, and now I'm going to create a Kubernetes cluster. Let's switch to standard one. So I'm going to name it my cluster without NEG. Let's say my cluster traditional traditional way traditional way. Okay, and then here I'm going to make it journal. Let's make it Asia South to A, because this is nearest to my region. And then go to the node, and here I'm going to select the small one, and I just need to. And in the networking section, you have to uncheck this option. If you don't uncheck this option, then this cluster will become a cloud native. So we are not going to make it a cloud native. We want to make it with the old one, the traditional way of doing the load balancing. So just unchecked it, and you're gonna create this. Create one more cluster. So I'm gonna name it my cluster NEG. So this cluster I'm going to make it network endpoint group, and everything will be same. The only thing that we're going to change is that we will select the cloud native option, and I'm going to make it same Asia South to A, and here in networking, this option in my first cluster, this option was unchecked, but in this cluster, I'm going to have it with the default. So I'm going to create this option. Okay, so it's saying the quota is full, so I might not be able to create it. Okay, so leave it. Let's complete this one, and I'm going to pause this video. And once this uh, the GKE cluster is on, then we will log in and deploy some service, and I'll show you how the traffic is going on. Okay. All right, so my GKE cluster has been deployed and ready to connect. So what I have done, meanwhile, what I have done, I have already connected to this cluster, and I already deployed some of the services at deployment and exposed it with the ingress. So I'll show you the code, what I have done so far. So this is my Hello World 1, the Hello World 1 deployment and Hello World 1 service. And this is my Hello World 2 deployment and the services. The replica is 3 here and 3 in 1. And this is my ingress rule. And I'm saying in the ingress rule that if the traffic is hitting on root path, then it is going to serve with my Hello World 1 deployment or the pods. And if a user is putting the subcontext like v2, then it is going to be served by the Hello World 2 deployment. So you can see that I just use this command to see my deployment. So these two deployment have been completed. You can see 3 by 3 replicas, and the pods are there, hello world 1 and hello world 2, three pods are there. And you have the ingress, and then you have the service. If you type here kubectl get ingress, then you will see that it has already created a load balancer for me. Let's see the pod on which node it is running. So you have two nodes, B2 and DXG. So you can see that uh, it is running equally, not equally. I think the four ports are running on this node DXSG, and the two pods are running on this node. So it's the Kubernetes algorithm that how it running their ports. So basically we have two nodes, and one node the four ports, and on the second node we have a two pods, right? So let's see in the console. If you go to a console and you want to see your deployment, you can see the deployment here. And if you want to see your service, you can see your service in the service tab here. And if you want to see the ingress, you can see the ingress is completed. It has created an external load balancer. This is the front end, and these are the services under these load balancers and the clusters. So this is my load balancer. See, this load balancer has been created by the ingress, and here you can see the three backend service. I'll show you why, and one instance group. So this particular load balancer is happening with a traditional approach, right? So because there is an instance group, no network endpoint. Just look at it. So this is your front end, and this is the host path and rules. You can see that. So this is the backend service, right? This is my first backend service. The first backend service is saying that the backend is going to be your instance group. You can see that here because we have two nodes, right? So that's why it is saying 2 by 2 healthy nodes. And then you have the second backend service, the second backend service, which is saying go to this node, go to this instance group, which is again having these two nodes, right? And this is the default one, which is for the default. Yeah, that is for the default cluster, the default IP, so you can ignore it. So these two backend services are important, right? So here, if you want to, hit this URL, let's hit this URL. If you put, you can see the traffic is landing onto your Hello World 1 version 1. Okay. Now, if you put V2 here, the traffic is now landing onto second deployment, my second, right, Hello World 2. So this is how that URL base or path base URL works, right? So if you look into the monitoring, so here you can see the traffic is coming from your load balancer, and then you have the URL rule. The URL rule is on the root path, and or everything from the root path, and then the V2. So you can clearly say that this backend service, right? This backend service is if putting your path without the subcontext, it is landing onto this backend service. If you're putting the V2, then this is landing onto your backend service, and but the instance group is same, right? You see that? Okay. Now what I'm going to do, I'm going to send some request just to see. So now I'm logging to my Cloud Shell, and from here I have a script which is written in Python and which will generate a huge traffic towards my load balancer. So let me show you my script. So this is my script, and here in the base URL, I have put it the load balancer IP on port 80, and I'm saying that 6,000 request is going to the count of request here. You can put the count of request, and then you're gonna save this, and now go to the terminal, and I'm going to hit this, hit, execute this script, and see this is sending a huge request towards my load balancer, and let's see how much time it takes to complete. So it took total time. So let's record this response on my notepad. Now, if you go to the monitoring here, if you go to the monitoring, you'll see a lot of requests are going to this backend service. You can see around 389 bytes, I think, and the request is going to this backend service, and the backend service is sending the request to your backend instance group, right? And if you see this small and thick, not thick, thin line, uh, this is the V2, because we haven't sent the signals or on haven't sent the request on V2. That's why this line is thin, because we have sent the huge traffic on default path, and that's why this one is this line is quite thick, right? So the next point is what I'm going to do. I'm going to delete this cluster, and I'm going to create a new GKE cluster with the network endpoint group, and I will also deploy the same service over there, and will also generate the same traffic to the load balancer of that cluster, and we'll see the response time. So let me delete in the background till the time I'm going to pause this video. All right, so you can see that my cluster with NEG has been deployed with 2 nodes. And I have also deployed the services, the same services which we have earlier deployed on our old GK cluster. So I have already deployed just to save the time. So this is my cluster. Cluster is ready. If we want to connect, we can connect it with this command line. But I have already connected, and I want to show you. So I run this command to get my nodes, and then I applied all these services, the hello world and hello world 2, and then the egress. You can see that all these pods are running, 3 pods from the hello world 1 deployment and 3 pods from the hello world deployment 2. And this is my pods with the IPs. And if you want to see the ingress, you can also see the ingress. You can see the my ingress has been exposed to created a load balancer. Now this is the point where we want to see the comparison. So earlier we have seen the load balancer where the backend service is managing the instance group, but since this is a GKE cluster and we have used that option, the VPC native option, and that's why we don't see that instance group anymore. But before that, before I want to show you my load balancer, let's first see the VPC. So if you go to the VPC and you see the default VPC, so you have multiple subnets. Since my cluster is running in Asia South 2A, which is in New Delhi region, so you need to see your region. So you'll see that this is your subnet, and you'll see some secondary range over here, right? Earlier it was not there because we have selected VPC native. The Google has automatically deployed the secondary range for our pod and for our services. So this is the primary range for my host for the node on that for the node of the GK cluster, and this the first IP range is going to be allocated to my pod, and the second IP range is going to be allocated to my service. So GCP Google automatically creates the route for your load balancer to talk to to this IP range. I mean, internally they reduce the routes with compared to the old one. So that is one advantage. If I show you the routes here, you can show that this is the only routes that is saying it's peering to the Google managed service networking APIs. So everything will be taken care from this route. So that is the route that will be responsible to routing the traffic within the pods. Okay. Now, very important point is go to your network service. So you see that the network, this is application load balancer. And here you notice that there are 3 backend service, and you will see there is no instance group this time. This time you will find 3 network endpoint groups, 3 NEGs. Earlier it was reversed, right? Earlier it was 3 instance group and 0 network endpoint group. But this time we have selected the native one, and then we expose the service with the ingress, and that's why we are using these 3 network endpoint groups. Let's explore this load balancer. This is the front end. This is again the URL path, host and path rules. Same. Here, just focus on here, this backend service. This is the backend service one. And the backend this time is the backend type is not an instance group. It's this time it is a zonal network endpoint group, right? It is a zonal NEGs. The scope is zonal, that's why it is a zone, right? And the healthy is 3 of 3 means this backend is now directing your traffic directly to the pods. So we have 3 pods, right? We have 3 pods running on hello world 1 and 3 pods running on hello world 2, right? So I'll show you both. So if you see this 3 of 3, if you just click on here, I can see this is the endpoint group and these are the endpoints. Remember that these endpoints are a combination of the IPs and pods, port of the pods, right? So if I show you the this if you just look at this command, let me just clear this. Okay, if I show you my pods IP, you'll see that like this. Let's focus on this hello world deployment. 10.48.0.14, 1.8, 0.15. These are the pods IP, and you'll see the same IP is attached to this instance, this network endpoint group. Okay, so yeah, even if your port gets deleted, added, it will automatically added here. I'll show you once we scale it, once we increase the replica. Oops. Similarly, if you want to see your second network endpoint group, you will notice your V2 hello world V2 deployment ports IP 16, 17, and 9. If you see here, 16, 17, and 9 is coming from hello world deployment 2. Right. So this is what I wanted to show you, the real comparison of the cloud, the container native load balancing and the default behavior of the load balancing. So let's do one thing. What we're gonna do? Uh, let's deploy some replicas 7 here, and I'm gonna deploy 7 here as well. Now kubectl apply -f. Okay, you don't need to um, uh, apply on ingress. So hello world 1, hello world 2, both the replica has been increased. If you just see the ports, you'll see a lot more ports are coming. So you see that it's one by one ready. And now if you see this, I'll just go back. And now if you try to look at it again, you'll see more counts here. Just wait for a few minutes, few seconds. See that? 7 of 7. You can see that 7 of 7. So if you look at this into the monitoring, so you can clearly see that the rule, the you know the let's do one thing. Let's grab the public IP and try to hit it. Sorry, let's take this. Okay, it's working. This should also work too. That is also working. Now copy this and go to your Cloud Shell. I already have a Cloud Shell here. And now this time I'm going to change the public IP and want to record the response. This time because the load balancer is directly hitting to your pods, the response time has to be fast. Right, so let's save it on the terminal and generate the graphic. So there is a little bit difference. I can see that response time is less as compared to the old one. So we can see that the response is fast here. And if you now look at the monitoring, you'll see some data here. You have to wait for a few minutes. Let's refresh it. To wait for a few minutes. Anyways, I think this is gonna take a time to load the monitoring. details. So I paused this video for a couple of minutes and then I resumed it. So I can see that the monitoring is now visible. And here you can see that I hit this request right on the default path. And that's why you can see that the request is coming from Asia and it's hitting to your load balancer first. And from your load balancer, it is hitting to your the ingress. From the ingress, it is deciding that the the URL rules are there. So this is for default rule. It says this is a backend service for the default rule, and then the backend service is forwarding the request to the backend instance, which is nothing but your endpoint, the network endpoint group 6A. So you can see total response around 390 byte, total response traffic, right? So this is the flow of the traffic in your container native based routing or load balancing. So this is how it works. Here I can't see the backend parts, but I don't know if because earlier I think this monitoring has been a little bit changed. If you want to see the real difference in terms of traffic response, then you need to come up with the scripts. I need to send a lot of traffic towards to both the cluster that we have created, and then you need to capture the time request, response time per second, and all this, and then you can compare it. But trust me, in this traffic flow using the NEG, the response time is faster because this time the request is balancing on the pods, not on the instance group, right? So this makes this tool powerful. All right, so that's it for now. I hope you enjoyed these videos. The network endpoint group topic is a little bit complex. If you move into the more or business requirement where you have to set up the network endpoint group in multi clouds or hybrid cloud, then this architecture is going to be very complex. So I'll come up in my next video. Maybe I'll present a demo on serverless network endpoint group, and I'll try to cover one more video with the hybrid NEGs. So in hybrid NEGs, what you're going to do, you will have this one more NEG here. You'll create a one more NEG. Sorry, my writing is bad. And this NEG will point to your AWS cloud where you have some nodes are running, right? Or maybe some GK clusters are running. So you can use this network endpoint group as well. But you have to have the interconnectivity set up or some sort of HAVPN to be set up. And we have the internet based and network endpoint group, which is nothing but it's basically when you create a network endpoint group, internet network endpoint group, you want to say that my traffic is somewhere on the internet, somewhere right, somewhere want to move, forward it onto the internet. It could be anywhere. So I might not be able to cover this demo, but because this is out of my scope, I'll try if I get the resource. All right, so this is for what I have. This is what I have for you to show. I hope you enjoyed this video, and if you have anything, any questions, please feel free to ask in the comment section. And yeah, don't forget to subscribe my YouTube channel. And if you liked it, please feel free to share it with the others. Thank you. Have a good day. Bye bye.